Hi everybody and welcome to our class. Today we're going to do electromagnetism all in one. So we're going to cover all the topics, we're going to talk about them, and I also choose a key questions. But the general idea that I want you to have today is when you approach a new question, I want you to read the keywords and understand, oh, I heard this thing, I heard this thing, it's probably going to be this equation, okay? Because we have a lot of topics, we cover many things, but everything going to make sense right now. Come fast and let's join. Wow, it's a lot of students. Where are you coming from? Come, sit down. Okay, so we're going to repeat everything, so you're going to hear it today. So, hello everybody. Today we have a really cool class. What we're going to do, we're going to do electromagnetism all in one, which means that we're going to learn all the topics in the right order as I see it, in order to give us the feeling when we read a question, what should be the equation or the topic that the question talks about, because there are a lot of subjects. So let's dive into it, and we're going to start, it's funny, but we're going to start with Physics 1. In Physics 1, we study this equation. Remember? And what we study in this class, in Physics 1, we learned that we have this force, mg, right? But in this class, we learn two new forces. What are they?
Magnetic.
Exactly. We have the magnetic force, which I think it's more complicated because we have this cross term. And also learn another force, which is? Electric. Exactly. So some of the question, I'm going to talk about this idea, these concepts. Let's do one question regards that. Okay? So the question is from 21 winter, A, question number 10. Okay? And this question, we have a device that's called spectrograph. And spectrograph, it's a real device that actually measures mass of particles. Okay? You have mass in your experiment, in your startup, and you want to understand how heavy it is, so you use this device. At the first region, let's call it region A, you have electric field that points that way. This is the electric field, okay? And here, in this place, you're going to have only magnetic field. So I'm going to draw here, B, and we have magnetic field, but actually the magnetic field is all over the place, yes? Only in this region, you also have an electric field, okay? And a particle come by, here's the particle, you have charge Q, mass M, and velocity V0, okay? And the particle going through this zone, and then do here a curvature and land at this location, which is going to be x equal to, let's do here x-axis, okay? X-axis equal to 0.06 meter, okay? 6 centimeter. And the question is, what is the velocity of the particle, okay? So we just learned this formula, right? Force balance, right? So I'm going to do force balance on each side, okay? I see electric field, I see mass. If I see mass, it's probably going to talk about forces, right? That's the idea of mass. How hard it is to accelerate this particle, okay? Clear? So at the first region, I know that sigma f x equal to m a x. If I see that the particle go in a straight line, what is velocity in that direction? Probably 0. And if the velocity is 0, the acceleration probably be also 0. So this term is really piece of cake, 0. What forces do I have here? Which kind of forces could I have here?
Electrical.
Exactly, I can have electrical forces. So electrical forces is really remind gravity, right? It's the same concept, right? It's just some property that is sensitive to the field, gravitational field, so charge sensitive to electric field. Good. So here we have Q multiplied by E, right? And in our case, Q is given, and E is this magnitude. In what direction? Minus x, because they already gave us the axis, right? Good. Another force that could be is the magnetic. We see this axis. What the x tell us? That we see the tail of the arrow, right? So the magnetic field in this direction. So we have Q, we have V cross B, right? I want you to notice that the magnetic force is a little bit more picky, right? You have also velocity, which we didn't have here, and also the cross product, which means the angle gonna play a role, okay? Sometimes, right? So this thing is equal to Q. The velocity in what direction? Actually, I don't care what is the direction of the velocity or the magnetic, I care about their cross. So how are we going to do it? Using the right-hand rule, right? So right-hand rule, I took it, and how it's going? Remember? So this is V, okay, V, like, right? V. So this is the velocity. And now I'm going to shoot the magnetic. So the magnetic is going in, right? And I'm going to punch, give a slap. This is the force, right? So the force of the magnetic is in the positive, the x direction. Good. So it's Q, V, B at the x direction. And that makes sense, right? Because plus x, minus x, they need to balance each other in order to give us 0, right? So it makes sense. Okay? Note that I didn't put here gravity. Most of the time, when we're talking about electromagnetism, gravity not going to play such a big role because the mass is probably really, really small. Okay? So, yes, there is here mg, but the mass is so weak and so small, so usually we're not going to put it unless somebody tell us you should put it, or maybe put here this arrow, which means G, there's gravity, note it, okay? Be careful, okay? So from here I can extract the velocity, right? So Q cancel out, right? Velocity is actually this term go to this term, the negative go to the other side, divided by B. Right? That's what we have. Good. But what we really cared about what is the mass of the particle. So this thing did not help us. Because what's happened to the mass? Cancelled out, right? So cameraman, follow me. So let's check what's going on in this region. Okay? So in this region, what kind of an trajectory I'm going to do? A circular one, right? So you see it, this path? So usually when a particle comes with the velocity and enter a region of magnetic field, it's going to do trajectory of a circle. So for that reason, I'm going to choose this kind of coordinate, right? The radial coordinate, right? So what are the forces that I have in this region? Only magnetic. Right now there's no electric field, okay? M is still alive, and what is the acceleration when I'm actually doing a circular motion? Yes, it's V squared divided by R, the radius, right? And from here I can actually extract the mass, right? The mass is, I can cancel one of the V's, you see it? Cancel one of the V's, and then I'm gonna have the mass here, R, Q, B, divided by V, and we already found V, right? We already have it from the previous zone, this part. So from that we have R, Q, B squared divided by E, okay? And this equation of the radius, you see here that we have some connection to the radius, is really important to the exam, okay? Because a lot of the times we're going to talk about this circular motion. And note that we can solve the question by just understanding, oh, this is the radius, which means it's 0.06 divided by 2, right? Because this is the diameter, right? So the solution is 0.0 Q B squared divided by E. Okay, good? Great. So we talked about the forces. Okay, let's take this to the side. Can you stop the video and start it again? Press it.